Section 8.4, Electric Potential. So just like an object has energy in a gravitational field, so if you hold something above the surface of the earth and you release it, it'll fall back to the ground. An object with a charge in an electric field has some amount of electric potential energy. If you release that particle in the electric field, it'll experience a force, it'll get pushed, and it'll move, and it'll have some amount of kinetic energy. So just like the gravitational potential energy is due to the mass, the greater the mass and the higher up off the ground it is, the more gravitational potential energy it has, the greater force it will experience as it's pulled back to the earth. The electric force and the electric potential energy of an object in an electric field also varies due to the amount of charge. The difference is that when we measure the potential energy of an object above the surface of the earth, the mass of the earth doesn't change, even if the mass of the object changes. When we deal with electric potential energy, the mass of each changes. And so rather than talking about what we call the electric potential energy, we refer to a different value which is known as the electric potential, which is the electric potential energy divided by the amount of charge that's in some region of space. So if we place some positive charge in some region of space, we can then essentially account for that amount of charge in that space and assign an electric potential to each point away from it. From the amount of electric potential at that point, we then only need to know the amount of charge that is placed there in order for us to figure out the electric potential energy and the force. Electric potential is very useful for amounts of charges that are fixed in space, charges that are not moving. You can then determine the electric potential in regions nearby in similar ways that you can determine the electric field. So when we talk about electric potential is measured in volts. 1 volt is equal to 1 joule of energy per 1 coulomb of charge. So for example, a 1.5 volt AAA battery gives 1.5 joules of energy to every 1 coulomb of charge that flows through the battery. So remember, we can assign electric potential to any point in an electric field independent of the amount of charge that is generating that electric field.